So when you substitute f dash of c is equal to 0, as usual you will get the critical points. 0 is the point of local maxima because its second order derivative is negative. So therefore f of 0 is equal to 12 is the local maximum value. If x is equal to c is a point of local minima such that f dash of c 0 gives you the critical point and then it is positive for the second derivative. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. So in this session, we'll be learning the absolute maximum and absolute minimum values of the given function, and also we are finding the maximum and minimum values through second order derivative test. So in the last session, from the help of first derivative test, we have found what is local maxima or what is local minima with the help of the first derivative test. And here we are going to the second derivative test. So what is this second derivative test? So here, as the name itself says, here we are going to find out the second derivative of a function and then we analyze whether that function has a local minimum value or local maximum value at some critical points. So what does it says? Let f be a function defined on the interval I and c belongs to I. So let c be some critical point belongs to I. Let f be twice differentiable at c. It has to be derived twice at the point c. Then x is equal to c is a point of local maxima if f dash of c is equal to 0 and f double dash of c is less than 0, that means negative. So when you substitute f dash of c is equal to 0, as usual you will get the critical points and again you are differentiating, and then if you substitute the critical points in the second derivative, if it shows a negative value or less than 0, then we say the point as local maxima and f of c is called as local maximum value. Similarly, if x is equal to c is a point of local minima such that f dash of c 0 gives you the critical point and then it is positive for the second derivative, then we call it as f of c has local minimum value. If f dash of c is also 0 and f double dash of c is also 0, then the test fails. Again, we will go back to the first order derivative test and there we analyze whether the function changes its sign to positive to negative to recognize it as local maxima or negative to positive to say whether it is a local minima. Find the local maximum and local minimum values of the function f given by f of x is equal to 3x to the power 4 plus 4x cube minus 12x square plus 12. So first, the working rule goes on like this. First find out f dash of x. So f dash of x, x to the power 4 is 4x cube. So 3 is a constant into 4x cube becomes 12x cube. Derivative of x cube is 3x square. So 4 3s are 12x square minus derivative of x square is 2x. 12 into 2x become 24x. Now we will take f dash of x is equal to 0. So this implies 12x cube plus 12x square minus 24x is equal to 0. So if you take 12 as a common factor, here 12 as a common factor as well as x as a common factor, you can take x as a common factor, then here you will get x square plus x minus 2 is equal to 0 here. So when you solve this equation, here you have 12. Since 12 cannot be equal to 0, I can equate x into x square plus x minus 2 is equal to 0. Now, let us solve this quadratic equation. When you solve it, you will get a factor that is x minus 1, x plus 2 is equal to 0. So, this implies x is equal to 0, x is equal to 1 and x is equal to minus 2. Now these are the critical points we obtained. Since this is a cubic equation, we will be having 3 roots for this equation. Now let us find out the second order derivative here. So f dash of x. So now we have f double dash of x. So f dash of x is 12x cube. When you derive it, x cube is 3x square, 12 3s are 36x square. Next it becomes 2x into 12 and 24. So thus this becomes 36x square plus 24x minus 24. You can also take 12 as a common factor here. If you take 12 as a common factor, then it is 3x square plus 2x minus 2. Now let us substitute all the critical point. What is f double dash of 0, f double dash of 1 as well as f double dash of minus 2. So let's see it what happens. If you put 0 in this equation, 0, 0 and here it is minus 2. Minus 2 into 12 becomes minus 24. Next put 1, 3 plus 2, 5. 5 minus 2 is 3 again. So 12 3s are 36 it becomes. Next put minus 2. Minus 2 whole square becomes 4s. 3 4s are 12. 12 minus 2 it becomes 10. Again 2 into minus 2 4. So it becomes 6. 12 6 are 72. Now here you can see clearly this is less than 0. This is greater than 0. This is greater than 0. So what does the second order derivative says? If f dash of c is 0 condition, here first condition, when you substitute f dash of c is 0, you will get the critical points. Then you will derive it. Then you will substitute f double dash of c. If f double dash of c is negative, then it is a point of local maxima. If f double dash of c is greater than 0, then it is point of local minima. So negative means it is maxima here. Positive means it is minima here. So now clearly we can say, so 0 is the point of local maxima. 0 is the point of local maxima. So if 0 is the point of local maxima, then find out what is f of 0. Therefore, f of 0 is equal to, so if you substitute 0 in the function here, then the value will be equal to 12. So this is the local maximum value. Now, and here 1 and minus 2 are the points of local minima. So therefore, if you substitute f of 1 here, so 1 if you substitute here, 3 plus 4 minus 12 plus 12 cancel, it becomes 7. And if you substitute f of minus 2, so substituting in this equation as x is equal to minus 2, you will get this value as minus 20. Since the function can have relative local maxima as well as relative local minimum, there can be many local minimum values as well as many local maximum values. Therefore, here 0 is the point of local maxima because its second order derivative is negative. So, therefore, f of 0 is equal to 12 is the local maximum value, and since these two are positive, it becomes local minima. Therefore, the value f of 1 and f of minus 2 will be the local minimum values. Next question, find two positive numbers whose sum is 15 and the sum of whose square is minimum. So, let us take two positive numbers here. So, positive numbers, let me take x plus y is equal to 15. And the sum of whose square is minimum. Let me take the sum as yes, that is they have given square of the sum, that is it becomes x square plus y square. I have to find out x and y such that this equation is minimum. Minimum means its second order derivative must be greater than 0. That is, it must be a positive quantity. So, from this equation, I can take y is equal to 15 minus x. So, substituting here, I get x square plus 15 minus x whole square. So, x square plus 15 square is 225 minus 30x, and here it becomes plus x square. So, therefore, the sum is 2x square minus 30x plus 225. So, let me derive it with respect to x here. That is here. So, let me take this as, so here I am going to write sum with respect to x. Now, let us derive this. So, what happens? S dash of x is equal to 4x minus 30, and since this is a constant, it becomes 0. Now, let us equate it to 0. So, then it becomes 4x minus 30 is equal to 0. This implies x is equal to 30 divided by 4. So, cancelling this, we will get 15 by 2. Now, let us put the value of x. Before that, let us find out second order derivative. That is, let us derive s dash of x. So, s double dash of x. So, derivative of 4x is 4 and minus 30 is a constant, it becomes 0. Clearly, the second order derivative is 0. So, thus what we can say, thus x is equal to 15 by 2 is a point of local minima. So, if x is equal to 15 by 2 is a point of local minima, this means, so it has a minimum value. This is a minimum. So, therefore, what I can write here, sum of squares is minimum, and hence x is equal to 15 by 2, and y we have taken as 15 minus 15 by 2, because I have taken y as 15 minus x. So, this again gives 15 divided by 2. So, these are the two positive numbers. Next, find two numbers whose sum is 24 and whose product is as large as possible. So, as large as possible means their product attains maximum. So, therefore, here let me take two numbers whose sum is 24 implies x plus y is equal to 24. So, this implies y is equal to 24 minus x. Now, let me take the product. So, product is nothing but x into y. So, let me take P of x is equal to x into 24 minus x, which becomes 24x minus x square. Now, I have to show that P of x attains maximum. To attain maximum, I have to get the second order derivative as negative. So, let's check P dash of x here. Then it is 24 minus 2x. So, put P dash of x is equal to 0. So, this implies 24 minus 2x is equal to 0. Thus, we get here x is equal to 24 divided by 2, which becomes 12. Now, let me take the second order derivative. P double dash of x is equal to, derivative of 24 becomes 0 and minus 2x becomes minus 2, which is less than 0. So, therefore, product attains maximum. Attains maximum. Since the second order derivative is less than 0, we get the function is maximum. So, therefore, x is equal to 12 is the point of local maxima. So, this implies x is equal to 12 and y is equal to 24 minus 12, which is equal to 12, or two positive numbers. So, these are the two positive numbers where the product of x into y attains maximum. Next, find two positive numbers x and y such that x plus y is equal to 60 and xy cube is maximum. So, given that x plus y is equal to 60, so and let me take p is equal to x y cube here. So, from this here, let me take x is equal to 60 minus y. So, I will take the function in the form of y only because I am expressing this completely with respect to y. 60 minus y is y cube. So, this becomes 60y cube minus y power 4. So, whatever you are going to derive with respect to y only here. So, now let us derive with respect to y. P dash of y becomes here 60. Derivative of y cube is 3y square. No need to write down dy by dx when you are differentiating y, because here we have taken function in the form of y and we are deriving with respect to y only. So, therefore, derive as it is as you have derived x previously. So, it becomes 3y square minus here it becomes 4y cube. So, p dash of y is equal to 180 y square minus 4y cube. So, put this is 0. So, p dash of y is equal to 0. This implies 180 y square minus 4y cube is equal to 0. So, we get 4y cube is equal to 180 y square. Cancel this. So, 4 1s are 4 4s are 16 to carry, 4 5s are 20. So, I will get y is equal to 45. Now, I got y is equal to 45. So, let me take the second order derivative of this function. So, this is the first order. P dash of y is 180 y square minus 4y cube. Let me derive it again. Then, p double dash of y becomes 180 y square means it is 2y. Minus 4 into y cube means it is 3y square. So, p double dash of y is equal to 360 into y minus 12y square. Put y is equal to 45 here. So, p double dash of 45 is equal to, so when you put y as 45, 360 into 45 becomes 16,200 minus 12 into 45 square. So, it becomes 24,300. So, on solving this, we get p double dash of 45 is minus 8,100, which is a negative value. So, if this second order derivative at the point 45 is negative, implies x y cube attains maximum. So, if the condition is satisfied, therefore, y is equal to 45 and x is equal to, I have taken 60 minus y, which is equal to 60 minus 45, which is nothing but 15. So, therefore, y is equal to 45 and x is equal to 15 are two positive numbers. So, these are the two positive numbers whose sum is 60 and the product attains maximum. Next. So, maximum and minimum values of a function in a closed interval. So, let me take an example. F of x is equal to x plus 2, where x belongs to an interval 0, 1. So, if you see this, f of x is continuous in the interval 0, 1, but you cannot neither exactly specify what is the maximum value or what is the minimum value for this function. So, if you plot a graph for this, so if you put x is equal to 0 here, since you can't take 0 here, so at 0 the value will be almost equal to some 2 here and it will be a straight line like this until 1. So, within this interval, the function is clearly continuous. But you cannot specify what is the minimum value. We can see that the minimum value is very close to 0 and the maximum value is very close to 1, but we cannot define it. So therefore, here the function neither has a maximum value nor a minimum value. But suppose if you replace this interval with a closed interval, then obviously I can say, here f of 0 which is equal to 2 is the minimum value, f of 1 is equal to 3 is the maximum value for the function. So this is how a closed interval helps us to find out the maximum or minimum value. Thus, in a closed interval, the function has its maximum value as well as minimum value at the particular point. Now here is one more graph I have taken. You have clearly seen that a function may have many relative local maxima or local minimum values. So it can have more than one local minimum values, more than one local maximum values also, because it is continuous and there will be a valley and hills like this. So example, for a sine function, if you take, it is a curve like this. So for each point, so for some neighborhood of points, the function attains a maximum value, and similarly for some points or some neighborhood of a point, the function attains a minimum value. So therefore, there are many different values where attain its maximum and many points where it attains a minimum value. But the function can have at least one maximum value and it is called as absolute maximum, and it is always greater than the local maximum value. Similarly, the function can have only at least one minimum value, and that minimum value is less than the local minimum value or equal to local minima. So here is a graph I have taken, and have taken the curve here. So at the point B, the function attains a minimum value, and clearly f of b will be the local minimum value. Similarly, at point C, here the function attains a maxima and it is a maximum value, local maximum value, because it is changing its path from positive to negative and here from negative to positive, and hence we can say this is a local minimum value and this is a local maximum value. But look at f of d here. So here the function has reached the minimum value, and there we cannot say whether the function is increasing or decreasing. It may stop there also, but this is the minimum value of the function, and thus it is called as absolute minimum value. And see here at point D, the function has its maximum value, but here we cannot say whether it is a local minima or local maxima by first order or second order derivative. So clearly here A is the point where the function has its highest value. So therefore this is the absolute maximum value. Hence in any closed interval, the function attains at least maximum value and at least minimum value for the function in a closed interval. Thus, we can say the function has its absolute maximum value as well as absolute minimum value. So thus what we can say here, f has a absolute maximum value and it exists at least once in the closed interval. I may be any closed interval here. So thus every function f has its absolute maximum value and it exists at least once in the closed interval. And similarly, f has absolute minimum value where it exists at least once in the closed interval. So this is what it can be considered. Now let's see the theorem here. Let f be a differentiable function on a closed interval I, and let c be any interior point on I. So I is a closed interval here because to attain a maximum value, because to attain an absolute maximum value and absolute minimum value, the function must be defined in a closed interval. Thus, when it is defined, and when there exists any point C in the interval such that f dash of C is 0, then it may be absolute maximum value, or if f dash of Z is 0, then f attains its absolute minimum value at the point C. Thus, we can clearly say in any closed interval, the function attains absolute maximum value or absolute minimum value at least once in a closed interval. Now, let's see now. Find the absolute maximum and minimum values of a function f given by f of x is equal to 2x cube minus 15x square plus 36x plus 1 on the interval 1, 5. So, first how to find out absolute maximum and absolute minimum. So, as in the case of local maxima and local minima, you are going to find out the critical points for this. Then you are going to substitute the values in the f of x with the interval a and b. So, here first let us derive it. F dash of x is equal to 2x cube is 3x square. So, we get 6x square minus x square is 2x, 30x plus 36. Now, let us put it as 0. Put f dash of x is equal to 0 to find the critical points. We get 6x square minus 30x plus 36 is equal to 0. Divide throughout by 6, or take 6 common factor and write only the quadratic equation. Then we get here x square minus 5x plus 6 is equal to 0. So, we get x minus 2, x minus 3 is equal to 0. So, therefore, the critical points are x is equal to 2 and x is equal to 3. So, after finding the critical point, what you are supposed to do? You are supposed to find out f of 2 as well as f of 3. But to find out absolute maximum as well as minimum values, you should include the interval end points. So, therefore, now we evaluate f of x at the points 1, 2, 3 and 5. So, find all f of x at the points. So, from solving the equation we will get the critical points. From the interval we will get the extreme points, that is 1 and 5. Now, we are going to find out f of x to all these points. So, let us find f of x. So, let us write f of x now. F of x is 2x cube minus 15x square plus 36x plus 1. Now, let us find the value f of 1. So, f of 1, when you substitute 1 here, you will get the value as 24. Next, we will find f of 2. When you substitute 2 in the place of x, you will get the value as 29. Next, let us substitute f of 3. So, when you substitute 3 here, you will get the value as 28. Next, we will substitute 5. So, when you substitute 5 in the place of x, you will get the value as 56. So, with the end points of the interval and the critical points, we will find what is the value of f of x. Now, clearly you can see here f of 1, f of 3 is a minimum values and absolute minimum value is f of 1. And similarly, you can see 56 is the absolute maximum value at the point 5. So, therefore, 24 is the absolute minimum value at x is equal to 1 and 56 is the absolute maximum value at x is equal to 5. So, and also we can observe that the absolute minimum value and absolute maximum value exist at the ends of the interval, because the interval here is from 1, 5. So, minimum value is at x is equal to 1 and absolute maximum value is at x is equal to 5. Thus, we can say the absolute minimum value as well as maximum values exist at the ends of an interval. So, this is all of the methods of finding the minimum and maximum value, or we can say the turning points of a graph with the help of derivatives. This completes the chapter Applications of Derivatives. We'll meet you in the next session with the new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.